This is Chapter 8 for the sine and cosine ratios. Now, what's the point of learning about sine and cosine? Well, the whole point of it really is to determine, well, how tall are things or how long are things that we can't really have a way of measuring to go. But really the question here is, how come this guy doesn't have a body? Well, the reason is because you're a smiley there, big boy. Let's get back to the question. So, how tall is the building? Well, since you don't have a big, long tape measure to be able to figure it out, what we can do is we can do some, well, surveying, which is using trig ratios, indirect measurement techniques to figure some things out. So when you have a tree, for example, and you want to find out how tall it is, if you know a couple of pieces of information, you can then use the trig ratios to figure out what the rest of it is. So the trigonometric ratios are tangent, sine, and cosine. Now, we already talked about tangent in the previous chapter. Now we're going to work with sine and cosine. Sine and cosine, along with tangent, are part of the three main trigonometric ratios, and they're memorized easily by doing this pneumatic. SOHCAHTOA, the chief. Good chief, SOHCAHTOA. Here's how Chief SOHCAHTOA works to help you remember it. And I got to tell you, you need to memorize this. It will come in so handy to you repeatedly over and over again. So the first part is SOH, S-O-H. Well, that stands for the sine is equal to the opposite over the hypotenuse. The next part, CA. Well, that is the cosine is equal to the adjacent over the hypotenuse. And then lastly, TOA, TOA, is tangent is equal to the opposite over the adjacent. It's a real simple way to remember this. It's pretty much universal, and everybody in math is going to know SOHCAHTOA, SOHCAHTOA, SOHCAHTOA. So you can learn it, love it, live it, and maybe even buy the t-shirt. SOHCAHTOA will help you in many, many ways and tricks. So how do you use this thing? Here's how it goes. How to write the sine and cosine ratios works this way. I've got a triangle, I've got TGR, and I want to write the sine and cosine ratios for G and for T. So let's start off with G. So here's G right here. So the sine is opposite over hypotenuse. It is always opposite over hypotenuse. So what side is opposite of G? Well, the opposite side is 15. So I'll put 15 right there. The hypotenuse is always the side that is across from the right angle, so that is 17. 15 over 17 is the sine of G. What about the cosine of G? Well, cosine is the adjacent over the hypotenuse. So to get cosine, first let's clear these off of here. To get cosine, cosine is the adjacent over the hypotenuse. So from G, the adjacent is 8, and the hypotenuse remains the angle, rather the side across from the right angle, so 17. So 8 over 17 is the cosine of G. So now we want to find out about T. So the sine of T is still opposite over hypotenuse. So here's T, the side opposite of T is 8, and the hypotenuse remains 17. Now what about the cosine of T? Cosine is going to be adjacent over hypotenuse. So the adjacent side to T is 15, the hypotenuse remains 17, and so we're done there. Okay, so write the sine and cosine ratios for x and y. Well, I'm going to do this kind of quick. So the sine of x is going to be the opposite side is 64. The hypotenuse is going to be 80, so 64 over 80. This can be simplified, but you don't have to simplify it, not really. Anyway, and then cosine of x is going to be the adjacent side, which is 48, over the hypotenuse, which is 80. So now we'll do the sine of y, 48 over 80. And then the cosine of y is 64 over 80. Please notice that we have some relationships here, that the sine of x is equal to the cosine of y, and the cosine of x is equal to the sine of y. An important relationship to keep in mind. So this is what you're going to need to do on the top of practice 8.4. You just need to write the ratios. You need to do nothing else with them. Just write the ratios. You'll be all set. So here's some notes for you. This is in lesson 8.4. So we got some talking here about the sine, and here's some things to fill in concerning it. It's what we've already talked about. So this is just to help you remember what's going on. And then they talk about an identity, and then the example of the trigonometric identity for the sine of x, and then here is filling in some things. Right here, this is simplifying these ratios here. That's not strictly necessary, but it is nice to do mathematically. So now, we need to use the trig ratios to find missing sides. This is the critical juncture, the thing you need to be able to do. So here's what I have. I need to know a few things. First, I got to find the given angle. So the angle is 35 degrees. We don't have a name for this angle. We're just going to call it the 35-degree angle. Then we need to determine what we have and what we need to know. So let's make a little list here. So what do we know? We know we have a 35-degree angle, and we know that we have the hypotenuse. Here's the right angle. Hypotenuse is 20. What do we need to know? Well, we want to find out x, and we know that x is opposite of the 35-degree angle. Those of you who are a little sharper probably have already figured out what to do, but let's just keep it going here a little bit slower. So we're going to choose the trig ratio that includes what you have and what you need. Okay, so what do we have, what do we need? Well, we got to pick one of these three trig ratios to be our deal. And then what we're going to do, since this is the sine ratio, we have the opposite and we have the hypotenuse, we're going to use sine. Then we create and solve a proportion based on that. Here's what the proportion is going to look like. I've got the sine of 35 degrees over 1 equal to x over 20. Now, most places you're going to see, you're not going to see the 1 in there. I like putting it in there because it reminds me that this is a proportion I have to solve, and then I know exactly what to do. Cross multiply, then divide. So I'm going to cross multiply sine of 35 degrees. Please keep in mind this is not 35 times 20, it's the sine of 35 times 20. You got to use that in the calculator and then divide by 1, but I don't really have to do that second part because if I divide it by 1, I continue having the same answers. So I've got the sine of 35 times 20, that is about 11.47. That's my answer. That's what x is. Now, using the cosine ratio. So they kind of given away what the answer to this part is here. But anyway, so we've got a flagpole, wire, and ground that form a right triangle. Now this is a classic right angle trigonometry question. Flagpoles, antennas, trees, things like that, all typical things that are asked of right angle trigonometry problems. Here's what we know. So we've got the wire is the hypotenuse of this triangle, and from the top of the flagpole down to the ground is a 35-degree angle. So we're going to use the cosine ratio to solve this one because we want to find the side over here that happens to be the flagpole. How tall is the flagpole? So we're going to use the cosine ratio. So we've got the cosine of 35 degrees. Remember, I like to write it as a ratio like that, 35, cosine of 35 over 1. And then I've got the height of the flagpole, that's the adjacent, over the hypotenuse, which is 20. So we use the cosine ratio. So this ends up being cosine of 35 times 20 is equal to the height. So we put that in, 20, hit the cosine button on your calculator, 35, and enter it, and it'll be there. Actually, on our calculators, it'll work either way. If you hit cosine of 35 times 20, that also works just fine. So it's about 16 feet tall. Now, using inverse of cosine and sine, we've got a right triangle that has a leg that's 1.5 long and 4.0 long. So this side here is 1.5, this side here is 4.0. We're going to use those inverse functions. So this is going to be the inverse of cosine because here's the angle A that's what we want to find. And what we're being given is we're being given the adjacent side and the hypotenuse. Here's C, that's the right angle. The hypotenuse is across from the right angle, so it's 4.0. So because of that, I have the adjacent and the hypotenuse, so I'm going to use the inverse cosine function. So I put 1.5 on top, I put 4.0 on the bottom. Now here's something that the book is telling us to do that is not strictly necessary to do all the time. What they're doing here is they're going to convert this into a decimal. Going to make 1.5 divided by 4.0 is 0.375. Don't really have to do that on most calculators, but if your calculator will not operate with fractions, you do have to convert it into a decimal. So let's just go with it and we'll use it as a decimal. So I'm going to find the measure of angle A is equal to the inverse cosine of 0.375. Here's how you access this on the calculators. You're going to hit second and then cosine, and that will bring up the inverse cosine function, put in 0.375, and you'll get 67.975687, etc., etc. So that means that the measure of angle A is about 68 degrees because we were rounding it to the nearest degree. Now, the next part of that question is to find the measure of angle B. Use the fact that the acute angles of the right triangle are complementary, rather. That means they add up to 90 degrees. So the measure of angle A plus the measure of angle B is 90 degrees because the third angle is a right angle is also 90 degrees. So I've got 68 degrees. That was the measure of angle A, and it plus measure of angle B equals 90. So we substitute and we find out that the measure of angle B is 22 degrees. So 68, 22. Time for you to do some work. Quick check, page 154. Come back, we'll check the answers. So here's number 1A. You needed to just write the sine of x and the cosine of x, sine of y, cosine of y. So we've already done that. That's all written out for you here. How are the sine of x and the cosine of y related? Again, sine of x is equal to cosine of y when x and y are complementary. That's only true when it's a right triangle. You're only going to be working with right triangles, but just know that you can use sine and cosine on non-right triangles, but that's a different story altogether. Question 2. In example 2, suppose that this flagpole is a little bit different, that the round angle is 50 degrees and that we don't know the angle up here. The length of this guy wire is still 20, so what do we got to do? Well, what do we know? We know the hypotenuse is 20 feet. We know that the angle is 50 degrees. What do we need to find out? We want to find out how tall the flagpole is, and the flagpole is opposite the 50-degree angle. Hopefully you've clued into the fact that I need to use one of the sine ratios, so I have the opposite side, I have the hypotenuse, so that's going to be the sine ratio. So I set that up. The sine of 50 over 1 is equal to x over 20. So I cross multiply sine of 50 times 20, that is 15.32 feet, and we want to find out to the nearest foot, so checking our precision level, so we want 15 feet is our answer. Find the value of x. Round your answer to the nearest degree. We're going to use some inverse trig functions for this. So what do we got? We got the angle of x, we have the opposite side, we have the hypotenuse. So which one of those is it going to be? Sine ratio. So we're going to use inverse sine. So I set it up as inverse sine rather, of 6.5 over 10. To get that, you're going to hit second and sine. That's going to get you the inverse sine ratio. So we multiply that out, and we end up with 40.54. We want to round to the nearest degree. 40.54 rounds to 41 degrees. What about this other one over here? So we've got to figure out what we got. From the angle of x, we have the hypotenuse, that's across from the right angle, and we have the adjacent side over here. So we're going to use the inverse of cosine. So I've got the inverse of cosine is equal to 10 over 27. Again, second, cosine gets us the arc cosine or inverse cosine function. Multiply it out, we get 68.26, round to the nearest degree, 68 degrees.